Okay, this is TempleOS 5-minute random code walkthrough, episode 13, and I'm your host, Terry Davis. So let's see where God takes us today. Alt-B, and it looks like we are in the compiler's lexical analyzer under if and def. So the compiler has a routine called lex, which is lex is almost the front of the pipe. You can imagine a pipeline going from the pipeline through the compiler. Starts with lex get char, then it goes into lex, then it goes into let's say parsing, then it goes into the optimizing 1, 2, 3, 4. Then it that's the pipeline. Okay, so lex is let's take a look when we compile a statement. Let's go to an if statement. So lex returns tokens. This is checking if this is after it got an if. It's checking for a parenthesis in an if statement. Then lex advances it past the parenthesis. Then it parses an expression, checks for another parenthesis. Lex advances it past the parenthesis. So lex can also you can also check the value. You can also use a return value of lex. Lex lex get char feeds into lex. So what lex does is so lex returns EOF if it gets 0. Otherwise, if it gets A to Z, or underscore, or the upper upper 128 characters, those are legal. It's not just signed characters. My compiler uses both. It uses unsigned characters. Anyway, so it can. My operating system can use the full range of 8-bit characters. My compiler. Anyway, so if you get an identifier, it returns an identifier. If you get a 0 to 9 as the first character of a token, then it calculates, or it advances. It reads in the other digits for an integer, and it returns an integer. What we were looking at was the if and def. So we got a pound character up here. We got a pound character. Where is it? So if the main switch statement got a pound character, and then we checked for a token. We got a token. We got a keyword. Keyword include. These are the normally these are the pre-compiler pass, but in mine they're merged into the lex. I don't have a pre-compiler, so all the pre-compiler keywords are so if and def is a pre-compiler keyword, and if it enters a state machine, there's a state machine for okay, I guess it's Okay. So if and def in the middle of a define, we have to, what do we do? I don't know. Anyway, so if we got an if and def, then we stay in a loop. This is advancing. Oh, okay. Now I understand. So if we got an if and def, we read a token. This is recursive. It calls itself. If the token is not an identifier, we bail out. If it is an identifier and it's in the table, it checks to see if the identifier is in the hash table. And if it is not in the hash table, we if and def, then we continue parsing normally. This goes into this continues the lex loop. So it stays in this function in a loop. And however, if it is defined, then if and def's false. So if it is defined, we stay in a loop, parsing characters until we hit another pound. And if it's a, you can have nestled ifs, pound ifs. So it has, this J is the depth that it's nestled for. So we scan, we read those characters, and finally when we get a pound, when we get a pound, we lex the token to get the pound keyword. And if it's an else, or we're back to 1, if it's an else and we're back to 1, then we break. And when we break, this will continue in the loop. So what we did, we just scanned in all the characters that until we finish the if and def. And it handles reading ifs and def. It handles nestled ifs, or nestled pound ifs. Okay,